This week I learned the difference between atomic physics and nuclear physics. I learned that atomic physics focuses mainly on the properties of atoms, especially due to their electron configuration. In atomic physics, the nucleus is involved, but only with regards to its overall properties. The nucleus is mainly viewed as a single massive particle in regards to its spin, mass, and charge. The internal workings of the nucleus are irrelevant. On the opposing side, nuclear physics deals only with the nuclei. It studies the structure of the nuclei and their reactions and interactions. I learned that fission is triggered by the absorption of a neutron, causing the nucleus to break apart. This results in the release of a highly radioactive fragment or fragments because the sum of the masses of the fragments is less than the mass of that original nucleus. If the mass of the fragments is equal to or greater than that of iron, the fragments will bind more tightly, resulting in a decrease in mass that comes off in the form of energy. Fission can yield large amounts of energy from the breakup of such elements as uranium, especially according to the Einstein relationship. Fission is the result of light nuclei being fused together, which results in energy being yielded. Because of the mass of the combined nuclei being less than the sum of the masses of the individual nuclei, fission is caused. If the combined nuclear mass is less than that of iron, the nuclear particles will be more tightly bound than they were to begin with. This causes the decrease in mass, which comes off in the form of energy. I also learned about nuclear radiation this week. I learned that radioactive decay is a natural process in which an atom of a radioactive isotope spontaneously decays into another element through one of three processes. Alpha decay involves the loss of an alpha particle, which is made up of 2 protons and 2 neutrons. Beta decay also occurs. For example, in tritium, the neutron spontaneously becomes a proton, an electron, and an antineutrino. The nucleus then ejects the electron or the beta electron and the antineutrino. This could also occur in spontaneous fission, which is the splitting of one atom into 2 atoms. Throughout these decaying processes, 4 different kinds of radioactive rays can be produced. For example, an alpha ray, a beta ray, a gamma ray, or a neutron ray. In my research for my final NEAT video, I also learned the physics behind the functionings of a nuclear power plant. This reaction begins with radioactive uranium atoms, which are used to heat the water by splitting through the process of fission. In my research and through interviewing a dentist, in preparation for the completion of Project 3, the exploration of modern physics, I learned the details of the ITERO system. I learned that it uses parallel confocal imaging to quickly capture a digital impression. Parallel confocal imaging uses laser and optical scanning to digitally capture the surface and contours of the tooth and gum structure.